Go eat, bro. Mine's going to bed. I'm scared to let him train, dude. I'm still waiting for 3-hour drive. Oh, yeah? Yeah, it really was. What was the bell in your answer? Y equals 1/2 x plus 13. Yes. All right, I got it. I got it wrong. I wasn't the right answer.
Alright, what we're looking at real quick, I'll get the abbreviated lesson here. We're solving systems of linear equations, which means we're finding the point where two lines intersect. So we could have one answer, we could be parallel lines and have no answers, or we could be the same line and have infinite answers. So that's all the stuff that we're going to be looking at with this. Okay? So, three methods that we've got for doing this. You could do graphing, which I'm not going to do very often because it's the least accurate. If your graph spaces aren't very good and you don't space it out right, it's just an estimate, so it's not very accurate. Substitution and elimination are what we did when we did this in Algebra 2, and those are the two methods that we're going to use in here as well. So if I had two equations here, this first one says 5x minus 3y is equal to -6, and then x equals 2 minus y. The directions or the problem says to solve the system. So all it is two lines. I'm trying to figure out where they intersect. This system is ready to solve using substitution. Reason I know that this one's ready is because the second equation has a variable solved for it. It's already got the x all by itself. So if I have a situation where one of the variables is all by itself, like this x is, I'm going to substitute. So this says x is 2 minus y. So all I got to do is take 2 minus y, come up here and substitute it in for the x. Okay? So I'm going to have 5 times 2 minus y. Just put the 2 minus y in the x spot. Minus 3y equals -6. Now what would I do to start solving this?
Distribute.
Good job. So it gets me 10 minus 5y minus 3y equals -6. Now what? Good job. Good job. So I got 10 minus 8y equals -6. Now we got a two-step middle school equation. What do you think? Not going to add it. That'd make it a 20. Subtract it. Good. I know that's what you meant there. So it gets me -8y equals -16. Attaboy, Mr. Hayden. So our y is 2. Now we're looking for the ordered pair where these lines intersect. That's my y. So it's going to be something comma 2. What do I do to figure the x out? That's right. That's exactly right, Hayden and Kaylee. I want to plug it back in, and I can plug it in either one of them. It doesn't matter. That second one is the less work because it's already got the x by itself. So it's going to be x equals 2 minus 2. So that gets me that 0. That's it. Those two lines intersect at the point 0, 2. Okay? No biggie on that. Okay? Now this one I've got says 4x plus y is equal to 5. 2x minus 3y is equal to 13. Alright, this one the directions are the same. Solve the system. We did substitution on that last one because it already had one of the letters all by itself. Does this one have an equation that has a letter all by itself? The top one kinda.
I need all juniors with charged Chromebooks to please come to the
period assigned.
The reason Hayden's looking at the top one is because that's a 1y. So if we wanted to use the same method there, what would I have to do, Hayden, to get that y all by itself? I'm just subtracting the 4x. So it'd be y equals negative 4x plus 5. So now, it's back there on the back still. Now we're taking that and we're substituting it in for the y. Okay. So we've got 2x minus 3 times, and I'm taking the y out and I'm putting in what y is. Negative 4x plus 5 is equal to 13. Alright, so what we got to do now? Boy, Hayden's on a roll. 2x plus 12x.
I didn't say that.
Rachel did. Or Aaron, what did these do? Minus 15.
But thanks.
You have been up until then. Is equal to 13. You've done well so far today, Hayden. Keep it up. Aaron helping you out when he needs to. Alright, what we got to do now?
Aaron, the one you think's good at basketball, I just say every day.
Aaron said I've got like terms right there. 2x and 12x gives us 14x.
Right.
Now you just got a little old two-step middle school equation to solve.
Add 15.
Okay, so it gives 14x equals 28. Divide by 14, so x is 2.
Right.
So we're going to have 2 comma something. Pick somewhere to substitute that back in. Okay, I'm probably going to do the one that Hayden modified for me. Over there where it says y equals, that one's already got the y by itself, so that one will be the easiest.
Right.
So I'm going to plug it in over there. That'll be negative 4 times 2 is negative 8. And negative 8 plus 5 is negative 3. Is that what you got?
Yep. Right.
Right. Okay, so that's a couple of them doing substitution.
That's what we're doing. Like all day.
Now we're going to do elimination, which I think is even easier.
Really?
Yep.
Well, that's good. Well, trig got harder this morning, so I need something easier.
What y'all do in trig today?
We're doing something with trig functions. I don't really know. Well, like she'll give you sine and some decimal number, and you got to figure out cosine, cotangent, cosecant, and all the rest. It's hard. Not hard, but not easy.
Yeah. We got to work at it.
Well, Baylor, if you can do it, as long as you're doing it. I'm just trying to get credit.
Alright, we've got negative 2x plus 3y equals negative 10. Then we got 2x plus 2y equals 5. The directions are the same, solve the system. The first two that we've done, we did by substitution because one of the variables was either all by itself or almost all by itself. This one I don't have that at all. Okay, I don't have a y all by itself or an x all by itself. They both got numbers in front of them. So I'm looking to see, well, maybe I can eliminate a variable. You can eliminate a variable real quick and real easy when they've got the same coefficient. So my x's here, not worried about the positives or negatives, just absolute value numbers. My x's both have a coefficient of 2, right? So I can get rid of those lickety-split, no problem at all. Think back to our good old Algebra 2 days. If I'm trying to get rid of those two x's, and one of them's a negative and one of them's a positive, what operation will I be using? Addition or subtraction?
Whoa.
Good, Rachel. If I add a negative 2 plus 2, that makes a 0. Okay, that's a note that Keston's going to wish she'd have made. If I subtract when they're same signs, I'm going to add when they're different signs, right? So negative 2x plus 2x is nothing. He gone. 3y plus 2y.
Y.
Negative 10 plus 5. So we got our y. Okay, remember that? That's not new. We did that last year. So I know my ordered pair where these two lines are going to intersect is going to be something comma -1. Make sure you put them in the right spot. Our y was -1, it goes in the y spot. Got to plug that back in somewhere now to find the x. You like the first equation or the second one? Second one. So I'm going to have 2x plus 2 times -1, which is 2x minus 2, right? Got a fraction here. You see the fraction coming out on this one? If I add 2, that gets me 7. Divide by 2. 7/2 or 3.5, however you want to write it. That's it. Nothing to it, nothing to it. Remember that, Grace? Shouldn't we? Yeah, what Grace said. All right, let's do one where we got to get it ready now. Today's stuff, this is the longest type of problem that we'll have. Reason this one's a little bit longer, it's got a couple more steps, is because it's not ready for substitution and it's not ready for elimination. Either one. So we got to get it ready for something. If I got to decide, I'm usually going to be leaning towards elimination. So that means I got to have same coefficients on variables. So I'm looking at those x's and I'm like, well, they got a 2 and a 3. Those are factors of 6. I could make my x's both be 6's, right? Y's, I've got a 7 and a 3. Those are factors of 21, so I can make my y's both be 21's. So that's just up to you. Do you want to make your x's 6's or do you want to make your y's 21's?
X's 6's.
Okay, excuse me. X's 6's is a little bit smaller numbers, so we'll go with that. What will we have to multiply equation number 1 by to get a 6x? 3. So we got to make sure we distribute that 3 to the whole thing. So it gets me 6x plus 9y
You just leave the 19.
equals 57. Is that right?
I think so, yeah.
57. Dustin? 19 times 3, 57. It's falling down on your job.
We'll take your word for that.
All right, what do we need to apply equation number 2 by? 2.
Yeah.
So that gets me 6x minus 14y equals -12. Okay, so we made our x's both have 6, so we can get rid of those. Will it be with addition or subtraction? What makes a 6x and a 6x become 0? Subtract. Very good. Same signs, you subtract. 6x minus 6x is nothing. He gone. 9y, pay attention on your signs, minus -14y. 9 minus -14 is what?
It's a plus.
What you said was? No?
You're going to add them.
Got to add them, so what is it?
23.
23y equals, same thing here, 57 minus -12.
69.
Divide by 23, and y is 3. Okay, find somewhere to substitute your y back in to get the x. This one's a little bit, there's not one that's already solved. It's a little bit more work. I'd probably do the top ones, all right? So 2x plus 3 times 3 is equal to 19. Just substituted that in. So it's 2x plus 9. Subtract your 9. Divide by your 2. So what y'all got? Oh, Grace.
I need all the seniors and sophomores that are dressed up for Spirit David, please go to City High School lobby. Thank you.
Seniors?
I got some beads on.
I'm going. I'm out here.
You can wear my jacket. Really? Eagle on the back of the
Yeah,
back.
what's it? Can I-
Painted it.
I'm back
this here.
You probably won't be able to fit.
Probably not.
Today's boring. Everybody shouldn't take out their class.
You're the only student to ever say that, Bailey.
So I want to leave class. Like, what am I going to do on lunch break?
How many players here? I'll go for you.
Are you serious?
Good move.
I like the pair too.
Good move. Did we finish the notes?
Nope.
Oh.
I know. Right.
We're almost done. We got like 2 weeks. We've been in here for hours.
I miss my dog.
Dog? Whatever dog. Do you run him over?
I did run him over. I just got him yesterday.
Yeah.
Alright, all of the ones that we've looked at so far have had one solution. They were the scenario that I showed you where 2 lines are going to intersect on one point. These last couple that we're going to look at are your special ones where it could be parallel lines that never intersect or where it's the same line that intersects all over the place. Yes, okay. Seniors and sophomores who were dressed up got called out to have their photo taken.
Oh.
Senior should be or something like that.
Alright, so looking at what I have here, I'm thinking I'm going to use elimination. Okay, do I want to make my x's be 8s? Do I want to make my y's be 4s? Okay, now we're going to see what Aaron said there. When I make my y's be 4s, it's also going to make my x's be 8s. That's because this is one of those strange ones. But let's go with what Aaron said on that. That gets me 8x plus 4y equals 24. Here I still had negative 8x, negative 4y equals negative 24. Now some of y'all notice, that's right, some of y'all notice something's crazy already. I'm going to go ahead, Aaron was talking about my y's, and my y's have different signs, which means this is an addition problem. So I'm adding 8x and negative 8x, that's 0, he gone. Negative 4y and 4y, that's 0, he gone. So all I have on the left,
To go separate spirit days, please come to the high school lobby.
all I have on the left is 0, but what do I have on the right?
Negative 24.
No, what's 24 plus negative 24?
Oh, that is.
Nothing, it's 0 also. So when we end up in that scenario with a true statement, because 0 is 0, that's no brainer, right? That means that it's the same line. And it's intersecting infinite many times. So when you get a true statement, 0 equals 0, 7 equals 7, negative 5 equals negative 5, you'll write infinite many solutions. Okay? So, what do you think you would write if you got something that said 0 equals 10? A false statement. Caleb, pay attention. What would you have then? No solution. Very good. Let's look at one of those.
Oh, yeah.
Alright, we got 4x minus 3y is 8. Then we got 8x minus 6y is 14. Alright, so we're thinking eliminate. Do we want to make our x's be 8s, our y's be 6s?
Doesn't matter.
I need all juniors that dress up for spirit day to please come to the high school
We all
lobby.
honestly thought you were going to roll
Okay.
walking in the room.
Caleb said it didn't matter. So what would I multiply the first equation by, Caleb? So let's look at that. That gets me 8x minus 6y equals 16. Now I'll write the second one underneath that. Some of y'all ought to notice everything on the left, everything on the left's the same, but the stuff on the right's not. That's your doorbell going off, tell you something's up. These have same signs, which makes this a subtraction problem. 8x minus 8x is nothing, he gone. Negative 6y minus negative 6y is also nothing, he gone. So I got 0 equals, what's 16 minus 14? 2. So we're looking at 0 equals 2.
That's not right.
That is false. Big bad math there. No, no, no. So we give that a no solution.
Wait, can we just go like a thing through the equal sign?
Yep, that'll work also. That is good, good, good. 0 is not equal to, not even in Cuba. I don't know.
What if it does?
They got problems.
They have no solutions.
That's good. Ah, now, remember last year in Algebra 2 when we did this stuff, then we took it to a next level where we had 3 equations with 3 variables. That's when the problems got really long and the ones that started taking a whole page of paper to do each problem and all that. That's where, yeah, it was fun times. Well, that's where we're going tomorrow. So that's what we'll be having to deal with then. There is a way to do them in our calculator. Tomorrow will not be that day. Chase, be quiet. Tomorrow will not be that day. We'll do them by hand tomorrow, and then the next day after that, we'll remember how to do them in our calculator. So then on test, you can do it either way. Okay, but we got to cover both ways first. Okay? And are you? Okay. Dustin said it's all right. So we're going to be Dustin. No. Yeah.
Is there an exit?
No, I did first period, but